Hi everyone, my name's Stuart Jefford and I'm an Assistant Director in PwC's Sustainability and Climate Change team. You might not associate sustainability consulting with a professional services firm, but we're a network of about 100 sustainability professionals in the UK, and we're part of a global network of about 500 people. And I'm going to spend the next 10 minutes talking about some work that we've been doing with Scottish Hydroelectric Transmission, who are the electricity and networks business that's owned by SSE plc, one of the big 6 energy companies. And we've heard a few things just from the speakers so far. We've heard about the importance of driving value, we've heard about the importance of data, and we've heard about the importance of transitioning to a low carbon set of infrastructure. And I think this case study speaks to a load of those topics, because what She Transmission got from this project was new data that helped them better understand some challenges which I think are faced by infrastructure projects more generally. And specifically, their challenges around how we best design infrastructure to make the best possible trade-offs between the negative impacts that we, unfortunately, that are associated with infrastructure sometimes, but with the positive impacts, which are the whole reason why infrastructure is built. So that's the first challenge. The second challenge is around how you can communicate those trade-offs in a simple way to those people that are going to experience those, for example, during the planning process. So for She Transmission, the way that they did that was to understand and measure those impacts in terms of the monetary value of those impacts. And that's what I want to talk about a bit more about now. So She Transmission came to us with a problem, and that problem was that they had to build a very large, or upgrade a very large line that went from the north of the Scottish Highlands down to the central belt of Scotland. And I don't know, has anyone heard of the Beaulieu to Denny transmission line at all? No, that's what it was called. And basically, why were they doing that? Well, they were doing it to connect all the new amounts of renewable energy that were being installed in the north of Scotland, where all the wind is, to the rest of the national grid. And they had to do that, they had to replace a load of pylons or towers, about 1,000 of them that were built during the 50s and 60s, with some new towers. There were only 600 of the new ones, but the problem is that they were about twice as high as the existing ones. And they had to do all this through areas that were renowned for their natural beauty, and also for their cultural heritage. And all this stuff was costing them somewhere in the region of £600 million. Now, She Transmission originally applied for planning permission back in 2005, and that unfortunately resulted in a lot of objections, which triggered a public inquiry, which itself triggered 17,000 objections to the planned line, and most of them related to the impacts on the landscape. They eventually were consented, granted planning consent in 2010, so 5 years later, but only then with conditions. Now, despite the fact that She Transmission had tried as much as they could to mitigate the negative impacts, they only got planning permission on the basis that they implemented and undertook 73 separate consent conditions. And all that would cost about an extra sixth of the overall project cost. So 5-year delay, extra sixth of the cost. Now, obviously, this was pretty unsatisfactory for everyone involved. On the one hand, She Transition knew that this kind of project is essential for exactly the kind of low-carbon transition that we've been hearing about, to connect renewable energy to the grid. But on the other hand, a 5-year delay in planning isn't good for anyone, and all the stuff that led to that was a real problem. So they wanted to find new data, new information about the values and the relative pros and cons of things to try and navigate that process better in the future. Specifically, how to design infrastructure so that it better made the trade-offs between the positives and negatives, but also to help improve the way that those impacts are communicated to the stakeholders that were affected by them, the likes of local government, local communities, and ultimately energy customers. So to do this, they asked us 3 questions. The first question was, what are the most material impacts of projects like this, and specifically this project? The second question was, which of those impacts is the biggest in relative terms? And the third question was, those 73 consent conditions, did they deliver value for money to the energy bill payer, who's ultimately footing the cost of these? So to answer these questions, we did a number of things. We started off going through a process to identify what the most material impacts were. And as you can see, they were all measured in lots of different ways. And we then went through a process to try and measure those things, building on the existing information that was out there, but to restate those numbers in ways that people can more easily understand, and also in ways that could be more directly compared. And that's by measuring them in terms of their monetary value, using principles of welfare economics that I can get into. Now, it turns out this is easier said than done. And I can talk a lot about how we came up with some of these numbers if people are interested. But at a really high level, we basically took a load of existing data from things like places like the environmental impact assessment, places like she transmission zone records, and also statistics from the UK government and from the EU, and also things like academic literature. And that gave us some of the data that we needed. But where we didn't have that data, we had to collect new data. And we did that from places like focus groups. And we actually ran 3 surveys that between them got responses from about 5,500 people around the country. So we took all that data and we stuck it into some models which basically established the ultimate impact of all the construction activities to ultimately the way that they impacted on people. And that used the principles of welfare economics to convert those into monetary terms so that the relative importance of those things to people, those impacts to people in monetary terms. Now in PwC, we do this using a framework that we developed called Total Impact Measurement and Management, or TIM for short. And this is basically a framework that builds, it's a set of tools and techniques that builds on existing guidance from places like the Treasury on cost-benefit analysis and policy evaluation, and combines it with the latest thinking around issues like natural capital accounting, which PwC has been at the heart of, working with organizations like the Natural Capital Coalition and leading companies like Puma and Kering, who have produced environmental profit and loss accounts. And we also combined it with the latest thinking on social capital accounting, which is something that's also coming down the pipeline, and that we've been doing some work on with the likes of the World Business Council for Sustainable Development and other leading companies like TUI, the travel company. So, what does all this mean? What do we get from all this? It all sounds very academically interesting, but here are the results. So, what you see here is the impact of that original planned line, so the line that never actually got built. And what it shows you is or I should say this visual is something we called the TIM wheel. It's just a way of presenting our results. We either call it a TIM wheel or a radar. You can let me know whether or not it looks like either of those things. But what it shows, you can see that it shows the most material impacts from construction only of the line. So what we didn't look at in this project was the operation phase. But it shows some reds. Those reds represent negative impacts. And it shows some greens, which represent positive impacts. And the relative height of those lines shows the absolute value of the welfare value, so the monetary value of those impacts. And you can see that by far the biggest one, perhaps no surprise given the number of objections, is around the impact the line would have on the landscape. But you can also see that there are significant negative impacts around the impacts on cultural heritage. So that's both the visual impact around cultural sites, but also the archaeology under the ground. And also a negative impact on the tourism economy, which we estimated, resulting from the fact that some people are less attracted to some of these areas because of this infrastructure. So they're the negatives, but you can also see some positives, particularly the positive impact from construction. And essentially that's the impact from spending in the construction sector. The reason why it's shaded is because there are some direct impacts from spending on your direct suppliers, but also there are knock-on impacts throughout the economy from their suppliers and their suppliers' suppliers. So it shows that too. Interestingly, the other thing it shows, the thing I find interesting, is that it shows, relatively speaking, those impacts massively outweigh some other things which we originally thought might be pretty significant, like the embodied carbon around that infrastructure. Now, that could be just a consequence of this particular kind of project, but it's interesting to compare these things directly to each other, which you can do now that they're expressed in the same metrics. So that's the line that was planned and that received all the objections. And this is the line that was actually built. So you can see, going between the two, the biggest change is the reduction in visual impact. But there are also sort of slightly smaller impacts from around cultural heritage and around the tourism. And you can also see that there's a marginal increase in the economic activity, the amount of GDP that this project supports in the economy, and that's just because there was more spending happening. So this answered SSE's first two questions. What are the most material impacts? And also, how do they compare to each other? And all this is actually giving them new information that they previously didn't have, and it illustrates a general point around the potential for generating new information in the infrastructure sector. Because for sure they would have had information about the financial performance of the relative two options of the project. They would have had a load of technical data from the environmental impact assessment, and they'd also would have had a load of information from the objections. They would have known that visual amenity was a big deal. But up till now, they wouldn't have had the means to bring those things together and compare them directly without using something more than just gut feeling. So that answered the first two questions. But what about the third? Were these things worth it? And to do that, we simply subtracted one wheel from the other to get the difference. So now this represents the avoided negative impact that those consent conditions achieved. And at this time, the greens, therefore, represent avoided impacts. That's the positive. And you can see here that most of that benefit was driven from the avoided impact on a landscape. But there are also slightly smaller drivers from cultural heritage and the avoided effect on tourism. But what this analysis showed us to do, when comparing it to comparing that total value, adding it all up and comparing it to the 77 million that they had to spend on these consent conditions, it allows us to estimate, basically, for every pound spent on those consent conditions, they deliver between £2.90 and £3.70 of social value. So in that sense, they were kind of worth it from, if you compare that to measures of value for money. But what I think is more interesting is actually when you dig beneath these high-level numbers, because to produce some of these numbers, if you take visual amenity, for example, so the impact on a landscape, the way in which we estimated that was by surveying about 3,500 people in the UK and asking them, basically presenting them with different combinations of infrastructure and types of landscape, and asking them what their willingness to pay was to avoid these kinds of impacts. And this is using fairly standard techniques that have been around in the sector and that governments use for about 20 years. And what we allowed us to understand was how much people value relatively different kinds of infrastructure and different landscapes. So what this schematic tries to show is some of that information. So you can see that basically the cartoons kind of show the combination of landscape and infrastructure, very simplified, I must admit. And the bars on the bottom show the relative value that people, basically how much are people bothered by these things. And it showed us some stuff that's really obvious, bleedingly obvious, like the fact that people prefer wooden poles in landscape to large infrastructure, fine. But it also shows some stuff that was less expected, like, for example, people are willing to pay, it turns out, in this example, the same amount of money to avoid the impact from a single pylon as they were pylons in parallel to each other, which suggests that if you're going to try and avoid these kind of impacts, you're better off investing by protecting unspoilt landscape than impacts landscape that's already got towers in it. The other thing it showed us was actually allowed us to put hard numbers behind how people prefer different kinds of landscape. So, I mean, what She Transmission, are using this for now is for a couple of different things. One, they're using it in the way in which they design their forthcoming infrastructure. So if they're comparing different options, the question is, so we know we need to deliver low carbon transition infrastructure. We know that we need to build stuff to do this. How do we minimize the impact so that we can get this through most efficiently? And we've got two options, and this allows us to trade off the different kinds of options that you might have in terms of a landscape impact. So that gives them insight into how they design infrastructure, but it also gives them insight into how they can communicate the impacts of that infrastructure to stakeholders to help do that in a way which people can more easily understand. So at PwC, we think that these kinds of challenges are going to be faced more and more in trying to meet the kind of demand that Amanda talked about to start with in terms of scaling up our investment and delivering these sorts of kinds of infrastructure. For example, trade-offs where on the one hand we have to deliver low-carbon infrastructure, whether it's low-carbon energy, low-carbon transport, but also it might be adapting to climate change, like through flooding. Whereas on the other hand, trying to do that in a way which addresses equally fundamental but completely different issues around protecting our landscape and our cultural heritage. And you only have to look at the debate around wind turbines over the last 4 years to see this happening. So to conclude, I hope that this case study illustrates actually a more general point, which is that valuing impacts, no matter how you do that, can give new sustainability data that previously didn't exist, that can help decision makers compare very different options with each other to try and make the optimal trade-off between the positives and the negatives. Furthermore, hopefully it gives a means of simply communicating that data and those impacts, that trade-off to those people that are affecting, to give in a language that actually non-specialists can understand, whether that's the general public or whether that's the board, to allow a common language to have that conversation and to make those trade-offs. So my personal view is that it's only with this kind of information, this kind of new information, that we're going to be able to deliver infrastructure that ultimately delivers the optimal outcomes for our economy, our environment, and ultimately our society.
Thank you very much, Stu. It's certainly this whole issue of trying to actually establish, the value, the monetary value of things which are, I suppose, quite hard to value. I suppose the work you're doing there it does actually attempt to do that. But can you really convince somebody whose back garden or whose a view out of their back window is going to be destroyed by something? Can you really convince them that it's worth you investing in that? I don't know.
Well, I mean, that's difficult, and if it's something that's happening in someone's back garden, I think that's you can't really argue with that. I think what's difficult, and this is the constraint that the infrastructure builders have to operate within. And I suppose for me, the question is how do you make the optimal trade-offs at the bigger picture between those kinds of unavoidable, in some cases, negative impacts, and the whole reason why you're building the infrastructure in the first place, which is if you like, delivering a greater good. And hopefully, by having more information about exactly where the best way of spending your money is to try and minimise the impact for the most people, that's hopefully how this kind of information is useful.
Stu, thank you very much. Sorry to rush you through there. And if there's questions, grab Stu before he legs it off out there. Stu Jefford, round of applause for Stu Jefford.